Hi, folks. Thanks for coming back. Hey, I'm Ron with Ideal Industries. In this series of videos, I'm covering some terminology, or actually some testing parameters that we talk about when we test catenary cable for certification tests using certification-type testers. And make sure the cable is, Cat 5e compliant or Cat 6a or whatever it is you want to test for. And in this video, we're going to talk about the impedance in a cable and what we call return loss in cable. Now, impedance in a cabling is kind of described as the total opposition to the flow of a current or a signal down a conductor at a certain frequency. And it's one of the more critical transmission line parameters we actually have to go take a look at. And it is frequency-based, and we actually measure it in ohms. Okay. Now, an impedance mismatch is when you got two things that are not the same impedance. And this can happen because of bad connections, kinks in cables. There's a lot of reasons it might happen. And, most of this energy is going to get past this bump in the road, so to speak. But some of it gets reflected back at us, and that's the part we need to actually go take a look at. Now, the impedance in a cable has three parts to it. There's actually what we call the resistive reactance, the capacitive reactance, and the inductive reactance. And, you and I, we look at two wires twisted together, we see a cable. But what the electrons are dealing with are a series of resistance and capacitance and inductance it's got to get through in order to get to the far end of a cable. So we can affect this impedance in a cable by affecting these different things. And if the resistive reactance, you can affect that by pulling on the wire, and all of a sudden 24-gauge wire becomes 26-gauge wire on it because you pulled on it really hard. But if you make good, clean connections, you don't pull on a cable too hard, hopefully you won't have any problems there. Now, inductive reactance is where signals are induced into the cable. And, it's interesting. We used to coil cable up in ceilings, I should say, like in a drop ceiling, because there was partitionable furniture down below here. And this furniture is going to get moved sooner or later. So having an extra 50 feet or 75 foot up there in the ceilings would avoid us having to actually pull a new wire off a rack. Turns out that all that coiling of a cable actually affects this inductive reactance, and it's one of the reasons why the industry does not recommend coiling a bunch of cable up like that anymore. Okay. Now, the last one I haven't talked about is the capacitive reactance. And, anytime you put current down to conductors or two wires side by side, they're going to build what we call an electrical charge between them, and we call that capacitance. And you can affect this by changing that distance between those pairs. Now, you'll probably know that when you do your terminations on your catenary cables, you're only allowed to leave untwisted basically a half inch of cable on either end when making up a connection, because it's adding to this what we call capacitive reactance, or this impedance in the cabling and distorting it. Okay, so that's basic impedance. Okay, now the return loss in the cable is actually all this reflected energy coming back at us from all of these impedance mismatches in cables, and having excess connectors or too many connectors in the cabling or splices or anything things can actually add to this reflected energy. Now, it's interesting, catenary cable is a 100 ohm cable. And it's interesting that the spec is 100 ohms plus or minus 15%, and things should be working fine. It's interesting that we built quite a bit actually headroom into the system, and the system still works. And that's how come you can take catenary cable a lot of times and kink it and knot it up, and it still works. It's because the system is designed to take this 100 ohms plus or minus 15%. So all the switches and routers and all the devices in a cabling all should be around 100 ohms is what we're looking for. Okay, but we could take a swing of 15%. And that's how come sometimes you could have a cable, say, at 85 ohms. You could have a connector at, say, 104 ohms. And a patch cord at 114 ohms, actually all within spec of this 100 ohms plus or minus 15%. Right? Now, this reflected energy, we call it return loss in a cable. And we want to make sure that we keep that at a minimum, because that reflected energy is actually distorting the good signal going in the opposite direction. So, again, we want to kind of keep it at a minimum. Okay? All right, well, there is impedance and return loss explained to you. Keep coming back to the channel, because I'll have more and more videos on this kind of subject matter. And, again, thanks for coming. Hey, I'm Ron with Ideal, and I'll plan on seeing you on the next one.